So like you guys have all said, the primary humoral immune response is slower and less efficient than the secondary immune response, humoral immune response, right? So the primary humoral immune response is going to be the first time that B cells get activated and see an antigen. So the B cell will proliferate, form plasma cells and memory cells, and the plasma cells can produce antibodies. So if we take a look at this graph here, it says the first exposure happens here, and then about 3 to 5 days to 7 days, depending on the individual, you'll see that we'll actually produce antibodies in response to that antigen. Okay, it could take about 3 to 14 days for this to fully complete itself. Okay, so we have a B cell that gets activated. It starts cloning itself. We make a few memory B cells, some plasma cells, and they'll secrete antibodies. In the secondary response, so anytime there is another exposure, a second, third, fourth exposure to an antigen, you're going to see that the response time, because of these memory B cells, is going to be a lot faster. It's going to happen within hours to a few days. So those memory B cells will start cloning themselves, will create more plasma cells this time, and even more memory B cells. Because we're making more plasma cells, we'll create more antibodies, and we get a faster, more robust secondary response. Here's another way to look at this graphically. So if you see here on the y-axis, it says time in days, and it says on day 0, we get first exposure to antigen A. About 3 to 5 days later, we're going to start producing antibodies to antigen A. And let's say on day 28, you get exposed to antigen A again. Within hours, you're going to produce a huge amount of antibodies much faster. And notice that they're going to stick around a little longer as well. There's something here that you also need to look at, that if you were exposed on day 28 to antigen A and another antigen, antigen B, you can be in a secondary humoral immune response to antigen A and a primary humoral immune response to antigen B. And the reason why you can have two different responses at the same time is because your lymphocytes are specific for antigens. And so therefore you can have a population of lymphocytes fighting antigen A and a population of lymphocytes fighting antigen B. So let's kind of put this all together, right? So the primary response is our initial encounter with an antigen. So here are some B cells. Notice that their receptors, their antibodies, these are IgDs on their surface, are all slightly different colors, indicating that they're specific for different antigens. This one in the middle finds its antigen, it gets activated. These don't. Okay, this one gets activated, and part of activation means that they're going to divide by mitosis and cytokinesis to form clones. So here are the clones. Most of the clones will differentiate and turn into effector cells. Those are going to be active in the current infection. The effector cells for B cells are plasma cells, which will secrete antibodies. Some of the activated B cells will be turned into memory B cells that will stick around and circulate the body, just waiting for another chance to see that antigen again. If the antigen shows up in the body again, a secondary response could be days later, it could be months later, or years later. That memory B cell will then activate very rapidly, clone itself, okay, and more plasma cells will be produced from this clone, and even more memory B cells will be produced from that exposure to that antigen again. And so you see a higher number of antibody molecules here.